Okay, so this video is on Dilations 2.7 A. So make sure that you have today's date right here. And what we want to do is just kind of talk about this triangle here. And imagine we had this triangle with these vertices, and we're going to change it a little bit. So let's just kind of draw a quick coordinate plane maybe. Just kind of track what a triangle looks like with these vertices. So let's see, we get this triangle. It's 1, 2, 3, 4 here. 1, 2, 3, 4 here. We'll make this the x-axis and the y-axis. So let's plot this first point at 0, 3. So that's right here. Now let's plot the next point at 3, 3. That's 1, 2, 3, 1, 2, 3. That's about right here, I would say. And then we'll plot the next one at 3, -1. 1, 2, 3, and then -1 would probably be around here. So we're winding up with this triangle. So let's kind of just draw this triangle, get a gist of what we're talking about here. This and that. So there's that triangle. We want to take a new triangle. We want to multiply each of the vertices by 3. So let's just look at that. So if I took this and I multiplied by 3, I'd have 0, 9. Okay? And we can already see that we're going to have some issues with our coordinate plane here. So let's take that and try to make that a little bit bigger. Let's see what I can do to make this work. I'm just going to try to extend it out. So let me just pause the video and try to make a better coordinate plane here. Let's do it. Okay, much better. We got a better looking triangle here. So now we got this thing, which we multiply both of these. We have 0, 9. So now I have this point right here. Let's make the new green point. Well, I have to take both of these and multiply them by 3. So if I take them both and multiply by 3, I have 9, 9. So I've got this over here, 9, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I'm right about here with that guy. And then with this guy, if I multiply these both by 3, I've got 9, -3. So I've got 9, -3. And this is the shape I would have then. I would have this shape right here. You might notice that it's like a similar looking figure. How are they related? Well, they are similar. I would say they're similar triangles. All the angles are the same. I would say that the sides are proportional. So like if the top of this side, for example, like right here, this is 3 units. This is 3, 6, 9 units. So it's kind of like triple the size, but the same shape. If this thing is 4 units, then I would say this is 4, 8, it should be 12, hopefully. Oops, I miscounted a little bit, so that's 4, 8, 12 right there. I went over by that a little bit. So that's basically what's going on. They're similar figures. So that's kind of interesting what we can kind of look at and is do that. So what I want you to do is draw yourself a new coordinate grid and try to do this figure right here. And then I want you to multiply. So first plot this, then multiply each point and coordinate by 3. So you might need a coordinate plane and then draw that nicely and then try to multiply each coordinate by 3. That's what's happening there. Pause the video, give that a shot. Okay, so now that you have done that, hopefully you can understand what a dilation is. I want you to find some space, maybe at the middle or bottom of that first page, and write this definition. A dilation, which is the key word today, that's what this note topic is about. A dilation is a transformation where a figure is made larger or smaller with respect to a point called the center of dilation. Center of dilation. Now I believe for our course, we're only going to have the center of dilation be the origin. So in this case, the center of dilation is always going to be right here, 0, 0. You shouldn't have to worry about other types. And you'll notice that when you take something at the center of dilation and you blow it up, you can kind of make this like little drawing where you kind of like draw lines from the different points. Like, so here's a dilated point from here to here. And then we have a dilated point from here to here. and you can actually draw a line. They're going to be collinear when you do that dilated point from the center of dilation. So write that definition, jot that down, and then we'll go to the next page. So is this a dilation of the red figure? That's the question. So here's what I would say. What you can do is you can kind of, you can do that drawing thing. So let's just take this and make a line here. So I'm just going to make a line here. It's not beautiful yet, so I'll make it better. So everybody see that line is kind of touching both of those points. This is one way of dealing with these things. Now let's make it over here. Okay, great. So now let's do that again. So we're going to make another line. Like this line. Okay. And there we go. And same thing. Good. Okay. So that's a dilation, because we can see that as long as these points can be connected in a collinear way, they've been dilated. And this is the center of dilation, right here. This is the COD. It's a dilation also just because, you know, the picture was blown up. It's made bigger. That's what a dilation really is. Just taking a picture and making it bigger. So that's, yes, it is a dilation. And here's kind of a nicer drawing of that. You can see that they're scaled up. The one figure, the blue one is smaller. The red one is bigger. And I guess if they're saying is it a dilation of the red, it is a dilation of the red, except the red gets smaller. The red was shrunk down. Is this a dilation? Is this a dilation? Well, so if we did our line test, I wonder how that would come out. I'm just kind of curious. So here's one line. Okay. And then what do? We make another line. You'll notice that these lines are not going to intersect. So this is not a dilation. All the like everything's the same size here, and when you connect the points, it doesn't make it bigger. Like you can't see it blowing up like that megaphone picture we had up here, kind of. You don't see that happening here. So no, not a dilation. They're congruent figures. They're not different sizes. So why don't you tell me whether this is a dilation? Pause the video, give that a shot. Whoops, this is the wrong one. Right here, tell me whether this is a dilation, this guy. And then tell me whether this is a dilation. So on both of those, I want you to tell me whether they're dilations. If you want to do the drawing in the lines, that's fine. So pause the video and try those two problems. So hopefully you've done that. You paused the video, you tried this one and this one. I want you to stop where you are, and I want you to actually write this down right here. So this is one more thing you're going to want to write down, maybe at the middle of that back page or at the bottom, wherever you can fit it. I want you to have this definition. So what's important here is the following. Right here, this is what's important. The ratio of the side lengths of the image to the corresponding side lengths of the original figure is the scale factor of the dilation. So in a dilation, this is kind of just a statement. In a dilation, the original figure and its image are similar. You can write that down, but what I want you to have is a definition of scale factor. We talked about the images being similar for a dilation, we know that, but here is more important, the ratio of the side lengths to the side lengths of the original is the scale factor. So in other words, if I have something like this, right, and we take it and we make it like this, okay, and this is 1, and this is 2, and this is 3, and this is 6, then the scale factor is 2. It was blown up, it was multiplied by 2. So that's pretty much it. What you're doing when you're going to dilate a figure in the coordinate plane, this is just something to kind of be aware of. All you're going to do is multiply the coordinates, the x and the y, by the scale factor. And that could be a fraction, a decimal, a big number, a small number. That's all you're really doing. So take the x and the y values and multiply them by the scale factor, which is here. That's all. And if the scale factor is, I don't know, let's say, if the scale factor is a fraction, then it's going to be reduction. So 1/2, 1/3, etc. So that's mostly all we have. There's one more thing I want to do. Let's see how we're doing on time. Pretty good. We're just about 10 minutes now. I like to keep this to about 10 or 12. We're going to draw this triangle, and then after a dilation, with a scale factor of 3. We're going to draw it, sorry. So we can draw the image and the dilation, I guess, would probably be the easiest way, I think. So what I'm going to do is I'm going to draw this image right here. So I'm going to do A1, 3. So 1, 3. We kind of already done this on the warm-up. B is 2, 3. B is 2, 3. C is 2, 1. 2, 1. So that's this figure right here. And we now want to take that figure and dilate it about the origin. So here is the center of dilation. And we want to dilate that by a scale factor of 3. So if we're going to take this point here by 3, we're going to have A, the new A, is going to equal, A prime is going to equal 3, 9. So I'll go to 3, 9, and I'll be here. B, the new B, B prime, and take this by 3, multiply that by 3, 6, 9. So 1, 2, 3, 4, 5, 6, 9 right here. And then C, the new C is 2, 1, so C prime is going to be 6, 3. So 1, 2, 3, 4, 5, 6, 3. And this is our new figure, and it is dilated by a scale factor of 3. And if you like that line thing, you can kind of draw the lines in like this and see that ideally they will all come back to the origin like that. So you can see that it was basically taken and then blown up. What would be a nice way to kind of show that? I would like to show that real quick. So let me try my best to show you. Get this set up real quick. Sorry, I'm going to pause and get this set up real quick. Okay, so what I've done here is I've kind of drawn this guy here just to kind of show you what's going on. We have this happening, and I want to show you, I made a little figure here. You'll see it. It's this thing. Okay, and it's a little bit weird to look at, so let me make it like this. So you can kind of see what's happening here. If I took this picture, and there's one issue with this, is that this is insanely huge. So I don't know if that's the best for it. Darn. So what I'm trying to show you is that if I took this and I put this here, right, did my best to kind of line it up nicely. Okay, this dot is obviously way, way bigger than it should be, so we're right here. But you'll notice that if I go up, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 3, which is this guy. I'm going to go up 9, and over 1, 2, 3, 4, 5, 6, which is this guy. And I'm going to go up, let's see, I'm going to go up 3, and I'm going to go over 1, 2, 3, 4, 5, 6, which is this guy. So we'll see that that's kind of what's happening here, is that you can kind of see that if you just took it and blew up the diagram from the origin. So here's the blown up picture, right? And now I'll shrink it down. I'll shrink it down at the origin, though. Shrink it down right to the origin. And you can kind of see right here that it will give you this image. Okay, so I guess that's enough for today. I'll stop the video there, and I will see you soon.